Tim OCONNELL Last updated 1741, September 25, 2017. Dr. Serean Adams, Cawthron Aquaculture Group Manager at the Cawthron Aquaculture Park. Embracing new species and technologies will go a long way to ensuring surging consumer demand for seafood is met, the aquaculture industry has heard. Speaking at the New Zealand Aquaculture Industry Conference in Nelson, Cawthron Institute's Aquaculture Group Manager Dr. Serean Adams offered insights into technology and research developments. "I think the industry has got a lot of challenges ahead. Sometimes you feel like you're stuck in the maze, but hopefully we can keep our eyes out for those opportunities going forward," she said. Biosecurity incursions may change the course of the journey, so we should not be thinking of it in the singular term but different futures and what that mix might look like. Adams said global trends provided some useful guidance, including increasing population demand, emerging economies in Asia and Africa, and an aging population. An extra billion people are estimated to be living on the planet by 2030, bringing increased urbanization as well as an increase in food and water demand. Consumer expectations would also continue to dictate industry movements as people looked for experiences instead of simply feeding themselves to survive, while valuing sustainability, fair trade and the need for innovation. Advances had been made in the hatchery production of new aquaculture species, especially geoduck, which sold for around $36 per kilogram in New Zealand, but fetched up to $110 a kilogram on the Asian market. Taharua, whitebait, hopuku and eel were also mentioned as either potential species to develop in the future or currently in early stages of farming in New Zealand. Long-term, spat reproduction and ensuring supply of seed and precision breeding would also benefit the industry, she said. Adams stressed the importance of resilience in meeting the future challenges, not just in terms of ecosystems, but also businesses' ability to bounce back from negative events. She highlighted recent examples of the Pacific oyster herpes virus, uncertainty of mussel spat supply and the Bonamia austria parasite. Cawthron began family-based selective breeding in the 1990s, extending to key species such as oysters and mussels in the 2000s. With the development of DNA technologies, researchers were now looking to make use of precision breeding techniques to pick specific traits and individuals, rather than breeding at a family level, Adams said. Choosing the right breeding method may prolong the survival rate and shelf life of aquaculture products, Adams said. It could also help to target specific consumer demands, such as the Asian market's preference for all-female mussels. Some of this work was being undertaken with Cawthron's Efficient Salmon program, linking breeding with individual fish behavior and metabolics to work out what is driving food conversion efficiency in New Zealand's salmon population. Adams also saw a large potential opportunity for whole farm utilization of byproducts which added value while reducing waste. This included seaweed being used as fertilizer and in 3D printing for medical devices. Video was also shown of a Lincoln University PhD student's experiment showing the effect of blueshell mussel waste in reducing the impact of pasture pest Costilla zealandica, or grass grub beetles, on vineyards. A 73% reduction in damage resulted from having shells on the ground underneath vines, while a 28% increase in grape yield was reported. In recent days, Cawthron had received funding for more research into prediction diagnosis and disease management. Adams said the new program would allow them to develop early warning detection systems to better predict outcomes, increase understanding while enabling better monitoring tools. "One of the challenges is that your stock is either alive or dead, and it's only when they're dead that you know something is wrong. Stuff